Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome, or hopefully welcome back to another episode of the Reliability Matters podcast. For those of you who are counting, this is episode number 122. When it comes to circuit assemblies, there are defects which result in one of two situations. The preferred result, if you have to have a defect, is to capture it on your factory floor and repair it before it ships to the customer. The second scenario is referred to as an escape. That's when the board ships to the customer and ultimately fails in the field. This is a scenario all assemblers dread and strive to prevent. One way to prevent escapes is through the use of automated inspection, or AOI systems. My guests today are Arif Virani, Chief Operating Officer and co-founder of DarwinAI, and Bart Piwowar, CTO of DarwinAI, a manufacturer of innovative inspection systems. Arif Virani has over 20 years of experience in our industry. As co-founder and chief operating officer of DarwinAI, he spearheads the company's mission to transform manufacturing with a new standard for quality inspection using artificial intelligence. DarwinAI's solutions have been implemented at top electronics manufacturers to increase quality and efficiency while reducing waste. DarwinAI was selected by CBInsights for its AI 100 annual list of the top 100 most promising private AI companies in the world, both in 2020 and in 2021. Before co-founding DarwinAI, Arif had a successful career in management consulting at McKinsey & Company, where he advised Fortune 500 enterprises on technology investments and transformation. He led several technology-enabled programs, including building and commercializing data and analytics capabilities. Arif started his career working as a software developer at various companies. In addition to his work at DarwinAI, Arif is an advisory board member of NGen, Canada's AI for Manufacturing initiative. He has a master's degree in business administration from the University of Pennsylvania's Wharton School and a bachelor's in applied science for computer engineering from the University of Waterloo. Bart Piwowar is an experienced product leader, leading high-performance product teams driven by data to deliver solutions that solve customers' problems. He has spent many years leading data science teams, applying innovation methodologies, and working with emerging technologies to bring solutions in many disciplines. He graduated from the University of Waterloo with a degree in physics and computing, and later followed with an MBA from the Wilfrid Laurier University. Bart's career interests range from AI product development, decision science, and entrepreneurship. I first met Arif earlier this year at the IPC Apex Expo in San Diego, California, where he introduced me to his company's automated inspection systems. Needless to say, I was truly impressed with their technology, and I'm thrilled to have both Arif and Bart as my guests on this episode of the podcast. Welcome, gentlemen.
Thank you. Great to be here.
Yes, it's great to have you. I have to tell you, when I hear your bios, it just reminded me of my earliest days in this industry. It would be back in about 1985, 1986. I was a college dropout, and somehow I landed in this industry, and I felt very, very out of place because of my lack of formal education. And I was speaking at a conference, and I was like the third in line to speak. And so the first person came up, and they had a bio about as long as yours. And then the second person came up and they had a bio even longer than yours. And then I went up and they went, our next speaker is Mike Konrad. That was it. And I'm like, I should have stayed just for that reason. I felt like I was the only one with no clothes on. So it is thrilling to talk to such accomplished people like yourselves. I love it when companies have interesting names. If I had a company, well, I do have a company, but I was smart enough at least not to call it Konrad Company, right? But I do like companies with interesting names. And your company name, Darwin AI, obviously references Charles Darwin, an English naturalist, geologist, and biologist, who's widely known for his contributions to evolutionary biology. I even saw some of your company videos and doing research for this episode, and I noticed your conference room is the Darwin conference room, complete with an illustration of Darwin on there. So that kind of builds up the pressure that if you're going to meet in that conference room, you better think evolution, right? So where did the company get its name from? Obviously Charles Darwin, but where did the genesis of that idea come from?
Well, Mike, it's great to be here on the show. And I mentioned to you earlier that Bart and I are both longtime listeners. You've had a lot of great guests on here, so great to be part of this company. But on Darwin, the background on Darwin is when you look at neural networks, they're massive in scale. So they're millions of parameters. And it's very difficult to get one of these neural networks to be efficient. So our original IP for Darwin was based on a technique called evolutionary synthesis, which was inspired by Darwin's studies on evolution. So when people build these neural networks that are millions of parameters, often they'll start with something that's publicly available. They'll pull it down from a system called GitHub, which is available to most developers, and then they'll train that on their own data. The approach that we used within our IP to make these models more efficient was we would take these initial models, take a couple of them, and then capture traits. And we'd all do this all through technology. We'd capture traits from those models and then evolve the next generation of models. And then we'd see how those models performed on the test data set. And then we'd evolve the next generation after that, all until you had a super evolved, efficient model at the end that performed very well in the data set. And that was the background for why we called our company DarwinAI.
Interesting. And Darwin, just the name Darwin has become synonymous with many things. One is evolution, and one is Darwinian theory, which is kind of a survival of the fittest kind of thing too. So time will tell if your company continues its evolutionary pattern. It seems to be going in that direction, and other technologies which are not as superior or as evolutionary will also survive. It's like the cell phone days. The original cell phones are very different than the cell phones we have today. We would never consider a cell phone that was analog, that had no screen, that had no capabilities of doing anything other than calling a phone number today. So I think that probably is happening in your industry, in the entire industry as well. Automated inspection systems, or AOI systems, have been around for many years now from a variety of manufacturers. And there are basically three reasons companies enter a new space or a space in general. One is when they invent a new technology, right? That's kind of the revolutionary concept of coming into business. Another reason is they might say, we can do that, and they just might want to be an also-ran and just throw their hat in the ring. And we certainly see a lot of examples of that. And another reason might be that they see room for improvement, that they have a better idea. And one example of that, going back to the cell phone analogy, is Apple. Apple didn't invent the cellular phone. I think Motorola did, or maybe even before that. And but they came up with an idea to evolutionize the cellular phone. So I think they have one of the highest market shares now of any manufacturer. And even though they didn't invent the technology, they also didn't invent the mouse. They also didn't invent the graphic user interface. They basically said, that's a great idea, and they evolutionized it. With your company, with Darwin, what was the how do you describe that reasoning? Say we can do that too. Do you think your product is an evolution of what has already existed, or do you really consider it more a revolution? Is there something so unique about it that it's really a brand new platform?
Mike, I'd say, keeping with that Darwinian theme, it really is an evolution of the AOIs that have been there in the past. So there's really three ways that it's building on the back of giants in terms of what's happened over the last 20 years. Number one, the technology that we have is very easy to use, easy to program. Number two, the solutions that we've come up with are low cost. And the third part is probably the most important. You can use our technology in places that you wouldn't have used it in the past. So going into each of those three areas, the first one, in terms of being easy to use, and this happened at Apex, people, it's funny you mentioned Apple. People, when they saw our system, they said that you all are the iPhone of PCB inspection, right? It takes, and the reason for this is typically it might take you a few hours or a couple of days to program a new product, right? If you're using a traditional AOI system. With our system, you can do that in the matter of a couple of minutes, and you don't have to have any specialization in order to do that. You need to understand the difference between a resistor, between a capacitor, an IC, but that's it. Any operator can can be able to program our system. And it's very easy to use in terms of getting around the interface. So that's the first part, being easy to use. The second part on low cost, because we're using artificial intelligence, and we built this system almost from the ground up, in terms of reimagining the types of cameras you'd need, the types of mechanics you'd need within there, we're able to get by with much cheaper hardware than traditional systems. In fact, we use AI to enhance the images that are being taken, so we can use lower cost cameras and still get really good imaging. And then the final part on being able to use it in different parts of your manufacturing process, your production process. Traditionally, AOIs have been used for surface mount technology, the SMT portion of the production process. When you look at things like through-hole, you look at final assembly, you look at conformal coat, you look at some of the cosmetic inspection that happens at the end, often you have people who are doing that inspection, or you may not have an inspection at all. Like going into a wave solder machine, you don't necessarily have a dedicated inspector for that portion of the process. So the fact that you can use this many more places across your production line is a big plus for our customers.
Yeah, I think this episode seems to be a tribute to Apple. We'll have to start talking about Samsung at some point to keep it fair and balanced. But I think one good comparison to what you're saying about using AI to reduce the requirement for more expensive cameras is, an iPhone. The iPhone's cameras rely on digital processing. I don't know if it's AI or not, but either way, they're relying on software to enhance. So a lot of things, for example, the latest releases of the iPhone, the 13, 14, et cetera, have really impressive depth of field capabilities that normally require that to be done through a lens and an aperture setting and an f-stop and all those things. This is all done now through software. It's an artificial depth of field. You get an artificial blurring of the background. It's not optically generated, but it's just as good, or at least from maybe a layman's standpoint, you couldn't tell the difference. So I totally understand that point. Let's talk about AI for a second. I just want to, because Darwin AI, the AI is in the name. AI is a funny word in that it's been hijacked by many companies' marketing departments. I see a lot of ads on television and online for certain products with AI. And, you just know that I don't think they're really aware of what AI is. And but it's become a catchphrase. It's almost like big data, everything's now big data. And it's just the marketing people have kind of bastardized the term and spread it around. Now, in your world, obviously, it is AI. But let's talk about AI for a little bit. AI has, in itself, gone through an evolution. And I'm curious what the evolution of AI was. I'm sure AI, it's not a 100-year-old technology. It's still in its infancy, but it's probably gone through several generations of growth and capabilities. Can you walk me through the technology of AI over time to where we are today and compare early versions of AI with where we are today and where you think AI is going?
So, Mike, if you look at the evolution of AI, the different generations of AI, there's really three generations that we went through. First is the expert system, and second is machine learning, which has been taking hold the last 10 years. And finally, we have this generative AI, and that's the one you hear in the news about recently over the last couple of years. So these expert systems, they've been around for a long time, essentially where people who are experts are working with programmers to program their knowledge into a system. And these are set up, they take a long time to set up because you've got to do a lot of meticulous programming to be able to address many of the edge cases. The challenge that you have is these systems are not very adaptable. And whenever you run into a situation that you haven't seen before, you've got to do a lot of programming to fix that and address that challenge. The new generation of systems around machine learning, this is really taking inspiration of how we learn as humans. So I have $2 at home. One is 4, the other one is 7. Neither of them knew when they came out of the womb how to differentiate between a dog and the cat. But by the time they were 2 years old, they figured it out. They'd seen a number of cats, dogs. They'd seen some other animals, rabbits. We have some coyotes in the neighborhood sometimes that come about, but and they were able to differentiate between the two pretty easily. Even if they had never seen that specific type of dog, they were able to tell pretty quickly when they saw a new dog, that, oh, this is a dog. I inherently know what it is. And machine learning works the same way in terms of seeing thousands, if not millions, of pictures of different objects, and then being able to discern, having a model that's trained on those, and then is able to discern what those objects are when they see a new one that they may not have seen in prior iterations.
Yeah, it's interesting how I never really thought about the fact that human intelligence, which obviously artificial intelligence is modeled after, is actually quite intelligent, because you're right, a 3-year-old will know a Chihuahua is a dog, and they'll know a Saint Bernard is a dog.
That's right.
And
that's right.
And they don't really look much alike other than 4 legs, but a cat has 4 legs as well. So you're right. There is a lot of almost intuition built into to intelligence, whether it's natural or artificial. Hadn't really thought about that before.
No, you're absolutely right. And the way that I would frame these initial machine learning models, they're very good at specific tasks, right? So with a 3-year-old or my 4-year-old, she's great at a number of different tasks. She can classify dogs and cats. She's able to pick up a glass of water, drink that glass of water. So there's a little bit of robotics, so many different tasks that they can do, even as a 4-year-old, right? You've got this great general intelligence that we would describe human intelligence. Machine learning models are very good at specific things, right? Specific tasks like classifying animals, as an example, right? The new generation of AI, generative AI, it's good at a number of different things because it's being trained on, like something like ChatGPT is effectively trained on all of the language that's out there on the internet, right? So it's billions and billions of pieces of data that's been trained on. And that's why it's able to do so many different language tasks, right? That were not possible before. So they call them LLMs, large language models. They're able to do so much more than these narrow machine learning models have been able to do over the last 10 years. And that's why there's a lot of excitement, and some people are actually a little bit scared about what their potential is in the future.
Yeah, to add to that, Mike, is we also have concept of AI efficiency in terms of data. So in other words, how many examples we need to show the AI to kind of figure out what that object is. So, going back to the child example, I have a daughter, I showed her, in a book, here's what an elephant looks like. Next time she sees a cartoon, it's like she just spots that elephant in the cartoon. It might look different color, right? So similar concept here with AI in our industry is how many examples of whether good or bad we need to show it before the AI kind of learns and incorporates that learning. The more efficient, the fewer examples required, and the faster we get to that efficiency.
Yeah, I'm going to ask you in just a little bit about something along that very line about, in your example, you talk about, a picture of an elephant and then they see a cartoon with a pink elephant and they still know it's an elephant. I'm going to ask you about the pink elephant of components when we get there. But first, let's go back in our Wayback Machine. Let's start with some basic fundamentals. Most of my listeners and viewers are within this industry, and most of them are at least familiar with the concept of AOI. But for just to not be presumptuous and kind of take a beginner's mindset, let's just give a real basic fundamental course on automated inspection systems. What types of, generally speaking, conventionally speaking, what types of defects are these systems capable of outing, so to speak? And then get into the AI component. Does the integration of artificial intelligence expand the traditional optical only view of defects?
Okay, yeah. So traditionally, we look at, three main categories of defects. So one is what we call like placement defects. Is there a component there or is it not? Is it skewed? Is it shifted? Is it tombstoned? Is it off the pad? So kind of placement of components. Should that component be there or not? Is it the correct component? And then the other category is what we call measurement type of inspection. So, for example, the amount of solder, the volume of solder, the amount of epoxy on a component, the level of underfill on a BGA, right? So measuring percentage or actual measurement in terms of centimeters, microns, etc. And the third category is what we call kind of cosmetic in nature, or sometimes called FOD as well. So foreign object on a board. So cosmetic in nature will be like scratches, dents, damage, foreign objects like dust. So those things. So the third category is probably the hardest for a traditional system to inspect, just because of the variance in that nature of defects. So think about scratches and dents. They can have different shapes, different angles, occur anywhere on a PCB boards, and that's really difficult to program that into an expert system. Now, leading your kind of question into, where's kind of AI have advantage here? So we think AI has advantage actually in all these categories. So in the first one, there's still a lot of variance in placement. So where's the variance come from? It could come from different lighting conditions. Sometimes the component just looks different. The supplier changed, or the same supplier, but now they have a different font that they're using, or it's off color for some reason, right? So there's a lot of variance that could come. And AI is really good at differentiating between what is variance and what is noise, and what am I actually looking in terms of a defect. That's kind of the key in terms of the AI advantage here. In the cosmetic one and the FOD is kind of a similar. So the AI can quickly learn the different variations of what cosmetics could look like, and can quickly distill the difference between noise and the different variations. So you don't have to code against all these variations in an expert system.
I was going to ask you about that. We're getting back to the pink elephant now, but you're giving me a perfect segue. With the supply chain shortages and all this drama that's going on in our industry and others, there's a big push to look for alternate components, similar in spec and performance, but perhaps different package, things like that. A different package might not be just a different font, right? It could be a whole different package. Can these systems adapt to learn that package A is okay, package B is also okay, and then look for defects within those different packages? Can they be trained to identify alternate parts without having to take another golden board image and train it on an entirely different assembly? How easy is it for them to either be programmed or to learn to accept maybe a little bit more than font or slight color changes? Does that question make sense?
Yeah, so that's a very good question, Mike. We see that a lot with our customers right now, especially for what you kind of said about the supply chain issues here. Yeah, so our kind of attempt at this is use the user interaction with the system to capture some of the feedback. So just because a component is different color or looks different, it doesn't mean it's alternate component. It could be actually a defect. Like could be either one, it's the wrong component, or potentially it's a fraudulent component, right? And the third option is like, yeah, that's actually an alternate component. So part of our strategy is we want to capture the user feedback to quickly incorporate into the model as fast as possible, so the model can learn, the AI can learn, and can say, no, okay, this new component here, the user said that's an okay component. Now I want to incorporate that, and now that color variation, the font, maybe slight different dimensions are incorporated very quick. It's almost like one-click feedback can result quickly in the learnings back into AI.
So it's as easy as it pops up a potential defect, the operator goes, no, this is cool, it's fine. And then from then on, it remembers it, right?
That's exactly how we have it implemented. You're right.
I travel a lot, as I'm sure you guys do. And, I've spent a lot of my life walking through x-ray machines and, metal detectors, all that kind of stuff. And some airports have the sensitivity turned up, and some have it turned down. I know that because if I'm making 3 connections in a day and I get through 2 of them and I haven't put any sledgehammers or knives in my pocket, all of a sudden I'll go through the 3rd one and all hell breaks loose, right? The alarms go off. Can any AOI system, and your system in particular, does the operator have the ability to adjust sensitivity, saying, don't be so critical? Can you? Does that make sense? Yeah. Is it very digital? Meaning, is it pass fail with no room for a little bit of tolerance? How adjustable is that?
That's a very good question, Mike. And practically what we see in the field is that, sensitivity is a real thing and different sites. So why is the kind of the operator needs that? One is some assemblies require different standards. So we, think about IPC standards, whether you're class 1, class 3, there's different sensitivities, what is good or bad. 1, 2, we also observe that within EMS companies, some of their customers require the assembly to be done for different standards. So you can have a line doing an assembly of one type of board and another one coming in, another batch, and then now suddenly like that defect is more sensitive to the non-defect that just passed through. So part of our kind of philosophy in the product, we want to put some of these tools and ability for the user to adjust the sensitivity on a per board, per component basis as needed to kind of adjust for some of the demands, whether it's from their customers or they're doing kind of looking at IPC kind of standard on what that good and bad is.
And Mike, that's where the machine learning is really powerful in terms of being able to respond quickly. The challenge with the traditional expert system approach is that you need to have a programmer who'd go in, make a lot of those adjustments, and the alternate components that you described earlier, a programmer would do it. And if you didn't do that, you end up with a lot of false positives or overkill, sure. Right? So the operator is always hitting the ignore button. And really, it's not just us, but there's an industry movement that's being led by INEMI to add AI to traditional AOI systems, because they found that false positive rate, especially in North America where you have like high mix, low volume lines, it's anywhere from 20 to 40% when you look at the number of false positives that you're getting. And being able to apply machine learning and some of those quick learning techniques can vastly reduce the number of false positives that you get while still maintaining the low level of escapes.
Yeah, I guess you don't want a situation where the operator is constantly hitting ignore. I know I'm a pilot, and I love looking at NTSB, crash reports. That's the morbid side of me, right? And I can't tell you how many times a plane has crashed because of pilot error, and that pilot error had to do with the captain or the first officer silencing an alarm because they just thought it was a frivolous alarm, and they get used to just hit cancel, hit silence every so often, hit silence, and then, and then they find out it was actually real, and it was trying to warn them of something, and they just thought it was just one of those like, it's glitchy. So yeah, you don't want to rely on your operator to hit ignore too many times because your operator's intelligence will get trained to, default to ignore, right? So we want to avoid that. What are some of the misconceptions that you see in AOI systems? I can give you one. I was talking to a colleague of mine within your space, and he said that he was quite amazed when a customer called and said that what setting do they need to use to see under the BGA? And it's like they mixed up X-ray and optical systems. But do you find that there's a common misconception about what these machines can do? Are they underappreciated? Are they is there a lower expectation or too high of an expectation in some cases?
Yeah, that's a good question. I think it comes down to, what kind of machine that you buy and how do you approach it. So, if you buy a machine and you staff it with a proper amount of engineering talent and programming, you potentially get good results out of it. So you have to kind of put in work to it to get good results. It doesn't come free by, having something on the ground that can get you kind of a quick kind of a turn on your investment. With AI system, might be a little bit different. So in our approach, what we're basically doing is shipping a product to a customer with foundational models, right? And those foundational AI models, they're kind of like the equivalent of ChatGPT, but we have a foundational model for electronics assembly. And those foundational models do a lot of the heavy lifting in terms of programming and configuring the board. So the user doesn't have to spend a lot of hours. So that's kind of one of those things where be careful what you buy because it could cost you a lot more in terms of programming than you initially thought, right? The second one is kind of related maybe to the programming aspect is, there's a lot of companies that are also offering what we call kind of kitted systems, like DIY systems or in machine vision for electronic assembly. So essentially what that means is like you can get a camera kit, some kind of a machine learning toolkit software, and then for a fairly low cost. And then here you go, kind of create your own system. And the danger there is that you end actually spending a lot more time in terms of programming, hiring some engineering time than actually if you just buy the whole thing done correctly, right? So that's kind of the other kind of a misconception in terms of kitted systems is that initially they might seem very cost effective, but in the long term they cost a lot of money in terms of support and programming time.
Sure, and you're not getting the advantage of scale. A manufacturer has some scale involved there, right? They're taking the cost of all that development, amortizing it over, thousands of machines, hopefully. You talked about, learning that the machines come, pre-programmed with, valuable set of knowledge. Machine learning, implies that the model gets smarter and smarter. It learns from its experience. And if I buy an optical inspection machine that has, AI capabilities, when does that learning begin? Does it begin learning with me? Is it learning, we all have children, many of us have children, and, my child doesn't benefit from the knowledge maybe another person in another neighborhood has, unless they're friends. My child has to start learning in a vacuum, from their own experience. In the world of AOI embedded or AI embedded optical inspection machines, does learning begin when it shows up at my factory, or as a child, or would I be the customer, the benefactor of all the other customers' experience and learning? And when it learns something, does that somehow go up into a cloud and get to you and go, hey, we're learning this down here, and that gets then embedded in the next generation of machines that go out. Does that question, I know it's a convoluted question, but does that concept, at least of that question, make sense?
Yeah, so let me kind of answer kind of a couple parts where like the concept of learning comes into play and the advantage of having that improved product, right? Because at the end of the day, we're going towards an improved experience, improved inspection system. So one is we ship a customer product that already has foundational models. The foundational models understand what electronics assembly looks like. It can identify parts on the board. It knows what the parts look like, where they're set, all that stuff. And also comes with already inspection algorithms. So out of the box, you pretty much don't have anything programming to do. Now, the reality on the ground is that every kind of EMS company, every assembly shops has some kind of small variations, whether they're using small different components with different variations. Maybe their boards look slightly different. So there's always that ability to fine tune and optimize for that customer. Now, how do we do that? So there are a couple of ways. So one is we want to incorporate the operator's experience with the product and their feedback into the machine. So as the operator's using it, they look at maybe a false positive, maybe they identify an escape. That feedback can be incorporated to the AI, and AI has the ability to kind of quickly reinforce itself to learn that aspect. And it's still an ongoing research when and what's the appropriate context where we want to incorporate that feedback, and when do we want to reject a feedback where it might be not appropriate. And then the other concept is around, okay, great. Now we have kind of a pool of customers. We have constant learning and improvements to the machine model. And the idea is that we also provide our customers with constant upgrade to the capabilities and some of the product capabilities. So think about like experience you have with your iPhone or a product where like, you can get a app update at any time with new features and capabilities. And those new features and capabilities basically came from usability testing across the entire, users that helped to kind of create that better product experience. So we have a kind of a similar philosophy here is that we kind of incorporate the experience from all across our customer base, including some of the improvements to the models, so that every kind of customer benefits in terms of the AI experience and new capabilities.
And Mike, there's different levels of this, right? In terms of what we as a company get back, and any company will get back in terms of the restrictions that certain people have around their data. So if you're ITAR restricted, that data is not leaving the facility where it's being used, right? Because that's very sensitive data that we don't want going anywhere. But there are some
That's a good point, especially with ITAR and things like that.
Exactly. And there are some customers who don't have products that are that sensitive in terms of the data, and they're able to share more with us as a company to improve the model that they get and that the others will benefit from. So it's really a little bit of a balance there in terms of figuring out what's the level of data sharing that's going to happen with a company like ours. In parallel, we're also amassing and this is something about AI companies, is you always want to have your own set of data that you're training from. So I like to say that we do a little bit of dumpster diving sometimes and get e-waste and all that, use that, and we'll train our models based on some of that data, and we'll get folks to annotate that data for us. But that the models are always getting better because we're amassing our own proprietary data set as well.
Sure. Are there certain types of defects that AOI systems just, I mentioned the example of looking under a VGA, looking for voiding or something under a VGA, but are there other types of defects that are just not real suitable, at least today, for AOI systems? And if so, will we get to the point where those types of defects can be detected, or are they just the realm of another technology?
Yeah, so we kind of mentioned like, cosmetic type defects where they're really difficult to program against with using expert systems, traditional AOIs. Foreign objects on a PCB board, that's another one. So a foreign object can occur anywhere and could be a different shape or size. You never know what the foreign object could be. It could be a solder ball, could be a piece of dust, a wire.
Right.
And AIs can spot that difference, or they're like, there's something there that shouldn't be. I've never seen that before, but it shouldn't be. And that's kind of the difference between, applying AI versus traditional systems. So that's kind of one area we see where there's a lot of benefit, where there's unfulfilled need in terms of cosmetic inspection, where AI has a kind of a proven solution here. The other one where we kind of like dabbled in, and I think its potential is even getting, think about, there's imaging system. An imaging system could be an X-ray machine, CT scan machine. And then there's, interpretation on how do I actually, look at the results. And a lot of these, these images that could come from CT, it's a 3D image, can take a lot of time for a human to interpret and look through. So there's a lot of potential for AI to actually advance that, the algorithms to look for defects, where traditionally humans we have a very difficult time to actually look for defects, very cumbersome, and leads a lot into kind of the human interpretation, what is a defect or not, whereas AI algorithms could be a lot more consistent in that answer.
Like it's almost like a different philosophy on inspection, where if you're looking at an expert system, it's focused more on the equipment. And when we talk about this AI-based inspection, that equipment that you're using to capture the image is not restricted to that one visual system. You can also use AI on the X-ray machine, on the CT machine. You could even integrate input that you're getting from ICT and use AI on that. Like that, the philosophy is shifting from like, let me do these point inspections and figure out what's going on, have a human maybe operating that portion of the process, to I've got a long production system. I'm getting data from every single point on there, and I want to sort out what's going on in my whole process across the board.
That makes quite a bit of sense. You talked earlier, I think Bart, you mentioned this about the interface, and we're an equipment manufacturer. The job I actually get paid for, we're an equipment manufacturer, and I'll tell you, a disproportionate percentage of our engineering expense goes into our interface, and it turns out to make a very simple interface is very complicated, right? Because you have to basically hide all the complications behind the curtain and only put on the screen what is relevant for the operator. And I call it guided discovery, and make sure we don't put anything on there too soon. Everything is responsive to, the situation. The interface has to have this degree of situational awareness, pre-programmed intelligence, right? You, in your on your company website and your videos, you talk quite a bit about the interface. So tell me, what's with the interface that you use? What is a typical learning curve if you were to just drop off a box at 8 a.m. on Monday morning? Realistically, at what point that day, that week, that year, that decade, would you expect a typical customer to be up and running and having that machine fall into a useful category?
Yeah, that's a good point. So user interface is a fairly important aspect of our product, and as we kind of deliver that to a customer. So the answer could be varied, but I would say our aim is that an operator or a user should be operational under 30 minutes. So should be able to quickly set up a board, configure some parameters, and should be able to start inspecting within under 30 minutes. That's our goal. And the average kind of what we're seeing on sites right now, it's around 20 minutes. And we're constantly trying to, get it lower and lower that so it's more simpler, faster. One of the philosophies that we have in terms of user interface is we kind of look at, the labor force at some of these EMS companies, and we see a lot of younger folks coming into the labor force, and they're kind of used to, the Instagram world, the Apple world, the Amazon one-click checkout, right? So we're kind of looking at that and saying,
instant gratification. Push a button and what you want is there, right?
Exactly. So when we're kind of looking at our user interface, a lot of times we're measuring is how many clicks does it take for me to get to some objective? And, the inspiration is always I'm always want to be one click away to get something done, right? And so that's kind of our philosophy. But you're right, the user interface is a very important aspect of the experience of the product. So even if the algorithm was super, state of the art, and it was super precise, if you have a faulty user interface, what it can lead to is, user errors. They're set up the machine incorrectly, or the user morale just goes down over time because they hate using the interface. So that kind of the last mile of the user experience is very important to us.
There's that emotional connection, Mike, in terms of using the software that operators have. And it's really, you want them to use it because they feel like they want to use it versus their managers telling them they have to use it.
Yeah, we find that in our equipment. If our equipment is forced on people, if they really wanted some other technology and they got stuck with ours, it's a struggle, right? It's a struggle. And the first people that we have to quote unquote sell on our stuff is the operator, and because the operators have to love it. They have to have that buy-in, and to minimize rejection by the people who actually use it. We have to make the experience understandable and easy and intuitive. Otherwise, they just have a lot of evidence against you. They go, it takes too many clicks. And I'm that way with websites. I'm a bit of an aficionado a bit of a critic of websites. If I have to hit, 4 clicks to get to somewhere, that's not designed well. I believe websites and interfaces should be very horizontal, not vertical, right? One click down, and you have a whole bunch of choices, and then maybe one more click, and then you have a whole bunch of other relevant choices. Not digging for oil. I think that's a poorly designed website. I'm going to ask one more question specific to AOI systems, and then I'm going to change the last few minutes of our conversation into kind of higher level. When someone's looking to purchase an AOI system from anybody, generically speaking, what are the types of questions do you think someone should ask? What questions help you drive a recommendation to a customer? I know you have offline and inline format options. What would you like to know that would make it easier and to provide a more realistic, reliable answer to the customer, as opposed to, I wish you had told us this before, right? We've all had that conversation with our customers. You never mentioned it before. Now all of a sudden, now it's harder. What kind of questions would you like to hear that would help you address the customer, fulfill their needs?
Yeah, so that's a good question. So a couple of questions we usually ask and kind of help guide the customer what they're trying to accomplish. So one is, we're in an assembly process. They're trying to put this, AOI or this inspection point. So we think about SMT lines. We have a pre-wave where through-hole components are inserted. There's a post-wave, pre-ICT or functional test, fine assembly or box assembly, right? So all these kind of assembly points would require a different inspection solution. And then the different inspection solution would mean potentially different optics and cameras. And as you kind of mentioned, what is the ideal workflow from a mechanics point of view? Is it inline? Is it operator driven, offline? The optics are probably one of the most important aspects there, because that determines what you're actually measuring or what you're actually inspecting and how optimal you want to be. So as an example, usually AOI machines that are at the SNT line, usually the camera is fairly close to the board and the components. There's not much clearance because most of the SNT components are fairly flat, and that's okay. But you can't take that same machine and put it at, pre-wave where through-hole components are there, where you potentially have, 3-inch big capacitor and the camera would just shear it off, right? So there's a limit there. So we usually, when we build our machines and our solutions, we optimize for that inspection point, whether it's enough field of view, enough clearance from a camera. We also want to have enough kind of focus in small, big components and see what we're actually measuring. So these kind of questions help us to kind of optimize to deliver the right solution at the right inspection point. The idea of, whether it's inline or offline. So generally the, EMS companies are going towards automation. So more inline things, removing kind of human from doing things. So inlines are becoming more popular. But again, we're looking at, inlines, there is a human component into it. Does inline mean fully automated, fully autonomous? Or is there a operator still kind of handling the inline aspect of it? So some of those questions will kind of come into play. And what is the idea for the customer to implement the inspection point?
I wasn't planning on asking this question. This is a completely ignorant question, but I was curious. When you're taking a picture of a board for the purpose of inspection, roughly how many pictures are you taking? Is it possible to take one picture, get the camera high enough, take one picture of the board and be able to provide the majority of the inspection based on that? Or do you have to go around and take these little micro photographs of various sections of the board?
Yeah, it's a very good question. So the answer is both, depending where we're taking the picture and what resolution or detail we need. Mm-hmm. As an example, if we're looking at just through-hole components and they're fairly kind of chunky, we can get away with, one camera just sitting up a little bit higher because we don't need that fine detail to look at very small SMT components or reading some, text value of them, right? And then that's an advantage because there's less moving parts, potentially just one single camera. But if we're looking at more detail, now we want to look at, something where we're inspecting through-hole components in addition to small SMT components. We need more precision. The camera has to be slightly lower, and we need more basically resolution in the image. So that way we need smaller field of view, and we're going to move the camera around to take multiple pictures. So again, it goes back to the question was like, what's the objective of the inspection and which location in the assembly process? And then we're matching kind of the optics and the setup to that point, right? And then the other one comes as like, okay, now what kind of image are we taking? There's, conformal coating. A lot of conformal coating have the fluorescence added to it. So that means, different lighting, and maybe camera that's optimized for UV lights as well.
Right.
So we have to kind of think about those aspects when we're kind of matching the proper solution for the right task.
Now you realize by the time we get to the iPhone 20 or 25, you're going to be selling apps. Someone's just going to take a picture of the board on their phone, and then the DarwinAI app will come up and tell you everything that's wrong with it, right? Yeah. That could happen. Let's switch a little bit more to philosophical. You on your website, one of your videos was talking about the use of inspection technology helps bring manufacturing jobs back to America. Now, whenever I hear that phrase, I always perk up. Our philosophy as a company is we build in Southern California. We try and buy all our parts within our city, or if not within our county, or if not within our state, or if not within our country. And if it's not available in our country, we buy it from someone in our country who goes overseas to acquire it, right? We like to have the inventory chain domestically based somehow, right? And that's just a philosophy of ours. It's not anything against other countries because most of the stuff comes from other countries. It's just I like to have the people who are responsible for making a living off of supporting us have a root here, right? And and then if we were building over there, we would do the same thing over there. When I hear, and I only say that because when I hear talk of bringing manufacturing back here, it always excites me. So tell me how the use of inspection technology can help boost up manufacturing in North America?
Like, I think you had this on one of your podcasts. There was a gentleman who came in and talked about making facilities in America very efficient using automation, right?
Yeah, and Patrick Stimpert from Matrix Group. Yes.
That's right. So when Patrick was talking about it, he said, like, if you're using automation, you're going to be competitive against anyone out there, right? Because that work is being done and it's facilitated more productive by putting a machine there. So that's what we find is that, and when you're talking about bringing back manufacturing to North America, to the US, Canada, we're finding, just speaking to executives at some of these EMS shops, it's not really an issue of, I need to really cut down my employee base. It's that my demand has gone up by 20%. And I've still got the same employee base, and I'm having trouble staffing these folks on different tasks, right? So if you can do things like take one inspector who is overseeing one area and doing manual inspection there, and then potentially have them oversee 3 or 4 automated inspection machines, right? That are taking over that task and almost act as an auditor on those 4 machines, you've made that person 4 times as productive. Or if you're able to put an inspection point where there wasn't one before, let's say it's before the wave solder, you're able to catch those problems before they happen and save on a bunch of free work, right? So you're able to make your team much more productive than it was in the past and much more competitive in the global landscape.
Do you build SPI systems as well?
We don't.
No.
We don't.
Okay.
No.
Next. Next. Make it so. Sorry, Bart, I interrupted you.
I was going to add to the question about the reshoring and stuff. So essentially, the AI has the potential to change the, calculate the labor efficiency calculation in North America, right? So instead of like inspectors doing inspection, non-value added tasks, now AI has the potential to relieve them. So EMS company can use them for value added tasks, and now we have automation of quality inspection. So the equation starts to change in terms of that high cost of labor in North America, right? Now, the question becomes, why haven't the North American companies have done this, 20 years ago, put more AOIs in the assembly process, automate more. And then the problem was, it's the economic barrier for traditional AOI systems is now high capital cost. And then 2, they take a lot of engineering resources to program them. So basically, if putting in AOI machines, you're basically just saying like, where's the most important place I'm going to put it in just one spot. But with kind of the AI systems and advances in optics, we can make it cheaper and easier to program and maintain. Now you can kind of enhance that kind of mid-end to back-end inspection.
Yeah, excellent. Your company, and again, researching for this episode, I looked at quite a few of your company videos on your YouTube channel, and I found a few of them on the subject of culture, company culture. So obviously that seems to be an important element within your company and many companies. We feel the same way. We have a very unique culture that one will either love or hate, right? And so tell me about your company culture. What's important for within your company culture, and how does that come out the other end to benefit your products and your customers and your team?
Like with our company culture, a good definition of it is you've got to, and this is tough in our industry, right? Because when you look at AI companies, we're competing with the likes of Google, Apple, OpenAI, others for our talent, right? They have their pick of where they can go work. But what's made us have a unique culture is that everyone here takes that learning mindset. Nobody feels like they're above anybody, and we're all learning in some aspects of our job. So I'm not an AI researcher myself, but I've learned a lot about AI over the last few years of being part of Darwin. Similarly, we have people on our team that are AI researchers who are really enjoying getting to know about electronics manufacturing and specifics on how things work in a line, how a pick and place machine works, right? Nothing that was in their domain before, but something that they want to learn, all with that intention of trying to use AI to transform industries. And it's in the back of right behind me. That's our company mission. But we want to not just keep AI in the lab, but try to get it out into real world applications and have impact with the AI that we've been able to produce. So that's really a big part of our culture, is that ability to learn and then the ability to apply. And then finally, it's also that way of how we treat each other, in terms of, if you take that learning mindset, there's very few egos in the company. People know that there's folks who know more about them in many areas. So you don't have that issue of that ego-driven management. And I find that makes it really open. In terms of the way that it manifests itself with our customers, is we apply that same learning philosophy when we're going to our customers and seeing how they want to use our technology within their own facilities. We don't go in with a very strong, this is the way that it needs to be done, but we're very open to hearing how their facility is set up, what they want to accomplish, and then helping meet their targets when it comes to first pass yield, or if it comes to reducing defects or scraps or whatever it is that they're trying to do.
Yeah, from a culture perspective, we're a very data-driven type company. We want to make decisions on data and kind of real-world kind of feedback to help us improve the product. Also, customer service is a very important aspect. We think about creating relationships with our customers rather than providing service, right? So we're very kind of customer-centric, and the entire organization has that aspect in mind, where if there's a customer issue or we need to resolve something, there's a lot of different kind of folks internally, whether you work in marketing or sales or engineering, kind of jump on board and try to kind of fix that problem for the customer. So having customer at the center is very important to us.
We're almost out of time, so just a couple more quick questions. Your company states it's organically aligned with the University of Waterloo in Canada, and that university has been described as the MIT of Canada. How does this alignment with the university benefit your company and its products and, of course, your customers?
Like in a number of different ways. First, the IP. So University of Waterloo has a generous IP policy, and we were able to spin out the IP from the university and make that part of our company without the exorbitant royalties that other institutions would charge. Second, we've done a lot of collaborations with the university when it comes to researching new aspects of AI. So things like explainable AI and efficient AI. We've done some collaborations with the university to improve our product in those areas. And then finally, we have a number of interns that flow through. It's a year-round thing where we're getting interns in different aspects of our company to work here in product roles, in engineering roles, AI roles, marketing roles, et cetera. And they just bring a new perspective every semester. And they're doing things that interns wouldn't normally do. So that's one of the pieces of feedback that we get from our co-ops, is that they feel like they're getting much more responsibility and contributing in a way that's almost like a full-time employee.
Excellent. And last question, from your perspective, get out your crystal ball. From your perspective, what's the future in inspection systems?
I'll start, and then I'll turn it over to Bart. I think that aspect of Industry 4.0, what people talk about, and you also had somebody who came and spoke about big data. You're getting all of these different pieces of data from inspection systems, from different equipment on your line. And the future of this is trying to put that data together, not just for actionable insights, but to take action on your production and improve it almost in real time.
We're trending towards that autonomous systems where machines are talking to each other and they're able to make decisions without the operator or human intervention. So they're adjusting things, they are making decisions. So you get a higher throughput, better first pass yield, and kind of also connecting to things and equipment that fail potentially in the field. So if something fails in the field, there's a question of warranty. Why did it fail? How can I quickly figure out what went wrong with my production system? And that speed to getting that answer, that's where we see kind of big impact in terms of the industry was heading. Right now, a warranty and kind of figuring out the root cause and doing that investigative work could take months to piece things together. But you want that basically in an instance.
And you want to be able to give that feedback to your operators who are on the line as well, right? So if you notice something that was off, for example, somebody placing a through-hole component incorrectly, and you've seen that pattern happen, you want to go back to that individual on your line and say specifically, you're placing this component the wrong way, right? And next time I want you just be aware that that's happening so that you can improve that in the future. And do that at different aspects of your line so that people who are involved in the process know what they need to do to change to improve.
Wonderful. Well, Arif Virani and Bart Piwowar, thank you so much for being my guest today. I enjoyed meeting you in San Diego. I enjoyed getting a tour of your equipment, and I thoroughly enjoyed this conversation. If my audience, if you would like to get in touch with these gentlemen, I will have contact information in the show notes. If you're listening to this on your favorite podcast app, just look at the show notes and you'll get some contact information there. Also, I'll put a link to their YouTube channel, which I found to be quite insightful. And even if you're not in the market immediately for an AOI system, if you want to learn more about AOI systems to see what maybe might be in store in your future, I found their site to be a good resource for that kind of information. Also, if you're watching this on our YouTube channel, just look down here somewhere. There's a button that says Show More, and click that, and you can also get contact information from my two guests today. So Arif and Bart, thank you so much for spending a little over an hour with me. I really appreciate that, and I look forward to seeing you out at another conference or another trade show or wherever we happen to meet again.
It was a pleasure, Mike. Thank you.
Thank you, Mike. This was a lot of fun.
I agree. Thank you. Well, that's another episode. Thanks for watching or listening to the Reliability Matters podcast. Our episodes have been downloaded more than 35,000 times, and I remain ever grateful for your support and encouragement. Don't miss an episode. Listen and subscribe to the Reliability Matters podcast on your favorite podcast app, or watch it on the Reliability Matters YouTube channel. If you're watching this on YouTube, be sure and click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. And a very special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments and episode suggestions to, right over here, to mike@mikekonrad.com. Just remember, that's Konrad with a K. Once again, thanks for listening or watching. Until next time, stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.